Ever wondered what could happen if a supernova occurred near Earth? Well, let's start by unraveling the cosmic mystery of a supernova. In the vast expanse of the cosmos, stars are born, they live, and then, just like everything else, they die. But the death of a star isn't a quiet fading away. No, stars go out with a bang, a spectacle so grand that it briefly outshines an entire galaxy. This is a supernova, the explosive death of a star. Imagine, if you can, a burst of energy so colossal, so blindingly bright, that it momentarily outshines all the hundreds of billions of stars in a galaxy combined. That's the power of a supernova. But these stellar fireworks aren't just for show. They play a vital role in the cosmos, spreading elements like carbon, nitrogen, and oxygen out into space, seeding the universe with the building blocks of life. Now, these events usually happen in the farthest reaches of space, light years away from our little blue planet. But hypothetically, what if a supernova were to occur a little closer to home, say in our galactic neighborhood? While the chances are astronomically slim, the effects could be astronomical too. A supernova is not just a light show, it's a cataclysmic event that releases an enormous amount of energy and radiation. If such an event were to occur close to Earth, the effects would be, to put it mildly, significant. But what exactly would those effects be? Would we be bathed in a beautiful cosmic light show, or would it spell disaster for life as we know it? These are not just questions for idle speculation, they're important considerations in understanding the universe and our place in it. They help us appreciate the grandeur of the cosmos and remind us of the delicate balance that allows life on Earth to exist. So, you might be thinking, what could possibly happen if a supernova occurred near our home planet? Well, hold on to your telescopes as we delve deeper into the Supernova Enigma in the next scene. To understand the potential impact on Earth, we need to first grasp the science behind a supernova. Dive with me into the cosmic arena where stars are born, live, and die in a spectacular blaze of glory known as a supernova. But what triggers such a cataclysmic event? It all starts with the life cycle of a star. A star like our Sun is born from a dense cloud of gas and dust. Over millions of years, gravity pulls this cloud together until the pressure and temperature at its core ignite nuclear fusion, creating a stable star. This star then lives out its life, burning hydrogen into helium, releasing energy and light. But as stars age, they start running out of hydrogen. When this happens, gravity begins to compress the star, and the pressure and temperature rise again. This time, helium is fused into heavier elements like carbon and oxygen, and so on, up the periodic table until iron forms. Iron, however, doesn't release energy when fused. Instead, it absorbs it. And this is where the magic, or rather, the catastrophe, happens. With no energy to counteract the force of gravity, the iron core collapses under its own weight in less than a second, triggering an enormous explosion, a supernova. Now you might be wondering, are all supernovas the same? Not at all. There are two main types of supernovas, Type 1 and Type 2. Type 1 supernovas occur in binary star systems when one star steals matter from its companion, eventually leading to a runaway nuclear reaction. Type 2 supernovas, on the other hand, occur when massive stars exhaust their nuclear fuel and collapse under their own gravity, as we just discussed. These celestial fireworks are more than just pretty spectacles. They are the universe's recycling program, scattering the elements formed within stars out into space, where they can form new stars, planets, and even life. Now that we have a grasp on the science behind a supernova, we can begin to explore how such an event might affect our planet. A supernova is no ordinary explosion. It's an event of unimaginable power. Imagine, if you will, a detonation so extreme it outshines entire galaxies. A supernova emits as much energy in a single moment as our Sun will over its entire 10 billion year lifetime. It's like detonating a few octillion nuclear bombs all at once. Yes, you heard that right, octillion. That's a 1 followed by 27 zeros. But a supernova isn't just a spectacular light show, it's also a cosmic particle accelerator. The shockwave from the explosion speeds up particles to nearly the speed of light, creating cosmic rays. These high-energy particles zip through space, occasionally colliding with Earth's atmosphere to create showers of secondary particles that we can detect. In addition to cosmic rays, a supernova also emits a wide range of electromagnetic radiation. This includes everything from radio waves and visible light to X-rays and gamma rays. The intensity of this radiation can be so great that it temporarily outshines all the other stars in its galaxy. In the heart of a supernova, conditions are so extreme that new elements are forged. The intense heat and pressure cause atoms to fuse together, creating heavier elements like iron, nickel, and even gold. Yes, the gold in your jewelry was likely forged in the heart of a dying star. In the aftermath of a supernova, a dense core known as a neutron star or black hole is often left behind. These remnants are some of the most fascinating and mysterious objects in the universe, providing a lasting testament to the power of a supernova. The power of a supernova is truly awe-inspiring. It's a cosmic event that showcases the raw energy and creativity of the universe, shaping galaxies, forging elements, and even influencing the evolution of life. With that level of power, it's clear a nearby supernova could have significant implications for Earth. But what would those implications be? Stay tuned to find out in our next segment. So, what would happen if a supernova occurred near Earth? Well, that's a question that could come straight from a science fiction novel, but let's dive into it. Firstly, supernovas release an almost unimaginable amount of energy, including a significant burst of gamma radiation. If Earth were in the path of this radiation, it could have a catastrophic impact on our planet's ozone layer. The ozone layer, as we know, is our primary shield against the sun's harmful ultraviolet radiation. Any significant damage to this protective layer could increase the incidence of skin cancer and other health problems among living beings. Apart from the direct radiation effects, a nearby supernova could also affect Earth's climate. The cosmic dust produced by a supernova could potentially block sunlight, leading to a drop in global temperatures, a phenomenon often referred to as a nuclear winter. This could trigger widespread climatic changes and have a profound effect on our planet's ecosystem. Now, let's talk about mass extinctions. It's a grim topic, but it's worth discussing. Some scientists theorize that supernova explosions could have been responsible for mass extinctions in Earth's history. The most prominent theory suggests that a supernova about 65 million years ago could have led to the extinction of dinosaurs. However, these theories remain speculative and are the subject of ongoing debate in the scientific community. But before you start planning for a supernova apocalypse, let's put things into perspective. The probability of a supernova occurring close enough to cause significant damage to Earth is extremely low. The Milky Way, our home galaxy, only sees 2 to 3 supernovas per century, and even then, most of these are far enough away to have little to no impact on our planet. While the thought of a nearby supernova is certainly frightening, it's important to remember that these events are incredibly rare. So instead of worrying, let's continue to learn and marvel at the incredible phenomena of the universe. After all, it's the curiosity and the quest for knowledge that makes us truly human. Supernovas, while awe-inspiring and powerful, are not something we need to lose sleep over. These spectacular cosmic events, as we've seen throughout this journey, are both a testament to the universe's power and an intricate part of its ongoing evolution. Indeed, supernovas are the universe's grand firework displays, a cataclysmic finale for a star's life. These explosions are so powerful that they can outshine entire galaxies, releasing an energy amount that is almost incomprehensible. Yet, it's this very energy that fuels the cosmos, scattering elements across the universe and giving birth to new stars and perhaps new life. But what about us here on Earth? The thought of a supernova occurring close to our home might seem alarming. However, it's important to remember that close in cosmic terms is still incredibly far away. The last supernova observed in our Milky Way galaxy was over 400 years ago. While the effects of a nearby supernova could potentially disrupt our planet, the odds of such an occurrence are extremely low. That's not to say we should disregard the power of supernovas. Their ability to affect planetary systems and their role in the universe's evolution are areas that still hold many mysteries for scientists. They are a reminder of the universe's dynamism and its constant state of change. So, as we stand on our tiny blue planet, looking up at the vast expanse of space, let's not fear the power of supernovas. Instead, let's appreciate them for the awe-inspiring phenomena they are. reminders of the universe's cyclical nature and the cosmic dance that's been going on for billions of years. Let's continue to learn, to explore, and to question. For it's through understanding the universe and its processes that we can truly appreciate our place within it. While we continue to explore the vastness of the universe, let's marvel at its wonders and respect its power, knowing that even the most explosive events in space are part of the cosmic cycle that makes life as we know it possible.